We're going to talk about callbacks and promises in Node.js, asynchronous programming using Node. My name is James Ciprianos. I'm the development manager for one of our engineering teams, Team Trogdor, here at Accusoft. So what stands behind all this asynchronous development is the idea that Node has a single threaded model. So anything that you do in Node is going to have some sort of event if there's non-blocking I/O. So if you need to read from a disk, talk to a database, make a web service call, any other kind of information that's non-CPU bound that's going to happen with some sort of I/O, it's going to basically yield control of what it's currently doing. The function will stop processing, let the stack continue, and then when it gets a return back from that asynchronous event, it'll continue on with your code. So this gives you asynchronous processing. You have a single thread, and you can do lots of work in it without blocking. So one of the common misconceptions and things that you can find a lot in searching for Node single-threaded is that the actual runtime of Node is single-threaded, and this is false. Node.js runtime is a multi-threaded C++ application. It's based on the V8 engine for JavaScript. It definitely spawns a lot of threads, but it allows your application in JavaScript to run on a single thread. JavaScript in itself is not a multi-threaded language. So all of your disk I/O, the timeouts you set, network requests, the V8 runtime is going to spawn a thread for those. You just don't manage it. It's an entirely managed system for threads. And so this little command at the bottom, which I've left in the slides just for anybody who comes in and wants to run this thing from the slides, if you run that in a Linux environment, you can see that when we run a small node process and immediately dump all the threads that it spawned, we get 5 threads just from starting a process that does basically nothing. So when you're looking at your code, you're running in a single-threaded environment. But what's actually happening on the server is lots of stuff being set up to handle letting you work in a single-threaded environment, not have to deal with that locking, not have to deal with that erase condition issue from the JavaScript engine. Also, since I skipped over it when I was talking about the hello world stuff, we do have a hello world in the thing that gives you Trogdor. So that's the most important code, and make sure you understand how that one works. It's very, very difficult code here. Oh. The question is, can anyone figure out where in our production code that exists? Everywhere. So benefits of this single-threaded model for Node. You get high throughput for I/O-bound tasks. So anything you're doing that takes a lot of reading and writing from disk, talking to databases, all those things that are I/O bound, the single-threaded Node process gets much higher throughput than a multi-threaded environment would for those types of applications. You also have much lower resource requirements for concurrent requests. So in the case of a threaded model, something like Apache or one of the other popular web servers, you're going to spawn a thread for every request that comes in. If you're using mod PHP, if you're using most Java clients, you're spawning a thread to handle a worker. To handle a worker request. That has to have some amount of memory and assigned to it ahead of time, and it's going to use that for the entirety of the time it's running, even if it's sitting there waiting on I/O and not actually actively doing work. So if you're using 4 megabytes of memory for each PHP request, and you have 100 requests come in, all of which have to read a file from a disk or make some sort of long-running request, you're going to use that many hundreds of megabytes of memory on your system. Node, on the other hand, will have a single thread with access to all of the memory on the system, assuming if you haven't limited it. And each request that comes in will only be running when it's not waiting on external I/O. So it's going to use the same amount of memory, the same amount of CPU, no matter how many requests come in. It's just going to bottleneck itself. It'll wait for the event queue and keep going there. So we have a lot less resource requirements. It's also a lot simpler to understand and troubleshoot than multi-threaded application code. Anyone who's written threaded applications before may understand the comic at the bottom here. With a single-threaded model, you obviously still have race conditions. You can write bad asynchronous code, but you don't have in the middle of running a synchronous process, something else happen on the system and change the state of my application. So it saves you from that headache. This is a general image of what the event loop in JavaScript looks like. Basically, as requests come in, and those can be web requests, they can be the actual command line call to run the Node application, they can be requests from some sort of event emitter on the system. They go into a loop, and they get put on a stack of events that are waiting to be responded to. When that event gets its turn, it'll run for a while, it'll do whatever synchronous processing is necessary, and if it has any asynchronous work to do, it'll register a callback. That goes into any sort of intensive operation, something that's going to happen outside of the main application thread. When that happens, the event loop continues. All the code continues to run synchronously across multiple ticks of the process, or of the process that's running. And as soon as that operation completes, your disk is done giving you the file back, you've read all the contents, then an event will be put on the stack and you'll be able to read the result of that process. So the terminology for that, we hope, there we go. The event loop operates on ticks. So those are one time through all of the code that's waiting to execute on the system. And when we have events in JavaScript, we can attach listeners to them. So anything we're waiting on, we can attach a listener and say, when this thing is finally done, when it comes off that long-running queue stack, let me know so I can, yes, I say queue stack, I got those confused. So each of the listeners is added in and will run once there's a result to run on. So you can attach multiple listeners to the same event. You can then execute however much you want, but it's not going to take up processing and sit in separate threads using memory until it's actually in use. And then each tick, everything is executed. So any code that's ready to execute will be executed, and it'll move on to the next tick. If there's nothing left, there's no events that we're waiting on, there's no synchronous code in the queue, then the process exits. So if you have nothing else that could potentially get into your system, you don't have a running server, you don't have an open port, your system will close. So I'll open up the event queue here. So this event queue here kind of shows, let's see here, node event queue. So we have two outputs here, the synchronous and the asynchronous output. And what we're doing is looping through the numbers from 1 to 10 and showing just how the process actually handles these. So the code's right here. You can take a look at that on your own, but I've actually got these in here. So this is the synchronous portion of the code. And what we do is we loop through, and for each one, we log out the output for that number, and then we immediately call the same function again. So we're doing it all within a single synchronous loop. We're not allowing the process time to have new ticks. We're not pushing things into the event queue. And so what happens there is we step through the function. Here's all the code that's being executed. And you can see we call the function the first time, we log it out. We then check the if condition. We call the function the second time because we passed the if condition. We repeat. We add some ellipses there so I don't have to go through this 10 times. And then when we finally get to number 10, we log it out, we check the if condition, we console log that we've ended the sync because our function return uses a standard stack-based function calls like any other language that we're used to. And on the second tick through the process loop, it's idle, there's nothing left to do, and the process exits. So in this case, we have no asynchronous waits that are happening. A slight modification of the system using process.nextTick. So basically, we've wrapped the call that says I want to go to the next number in a process.nextTick. That tells this thing that I want to take this and delay it just until the very next tick of the processing starts. It's very similar for those of you who have used set timeout to setting a timeout of 0. There are some optimizations that are made for this for Node, but the general idea is I want to allow other asynchronous events to happen. So if I was running something that was very intensive, I could wrap recursive calls in process.nextTick and not completely consume the CPU of the system. So when running through this one, I define the function, I start async, I call the first function, everything happens just like before, but now I call process.nextTick, which then means save that for the next tick, keep your synchronous processing going, which is why I fall down into the end async line, which is why my output for the asynchronous part actually has end async before it's actually done with all the processing, because I've actually completed that synchronous process. Then the second tick of the process occurs, runs just like before, and we do that 10 times. We end with a call to the 10th tick, and then on the 11th tick, the process is idle and it exits. So this lets us, if this were an actual CPU-intensive process and not something that happens pretty much instantaneously, it allows us to interleave requests in between this supposedly processor-intensive code. So Node has gotten a lot of popularity for web applications. I'm actually wearing the gaudy I Love Node shirt because we just got back from a conference where IBM was there talking about their acquisition of Strong Loop and how they're kind of moving to Node for all their new web application development. So Node has historically been along with a lot of other scripting languages, a startup-based, small company-based thing. It's really moving to the enterprise now. So web applications are kind of Node's home turf. The single-threaded model gives you very high throughput for web requests. So a lot of times you get a web request in and everything you do is IO bound. There's very little computation that goes in for a web request. Almost everything is just waiting on data from somewhere. You also have the ability with these asynchronous responses to not completely wait till it's done before you return back to the client. So you can make much more responsive feeling web applications if you have some long-running process on the server and you don't want to wait for it to complete. Doing the same in some of the completely synchronous languages is possible, but usually have to spawn another thread, manage that thread, make sure that you follow up when it closes. Here you can do it all right in your handling code and just return the response whenever you're ready. Whoops. So we've got a web server here. And basically this server does delayed responses. So it goes through and it tries to make a microservice call, looks up a record in a database, and encodes a video. And all those do is delay for 1.5 and 8 seconds. So we're simulating having some long-running processes, and we're going to look at what happens if we do them entirely sequentially, do all the processing, then return to the user, like a synchronous language would do. Or if we let Node say, as soon as the database lookup is done, I can assume the rest of this will run fine in the background, so go ahead and tell the user we're done. Clear. So we start up the server. In the synchronous call, you can see everything happens. The client is still sitting there spinning on their browser and waiting. Video is about to be done encoding. And we get a response back. Now we try the asynchronous request. The client's already gotten their response back that they're done. And on the server, we're now starting to encode the video. So the basic idea is, because your thread is not owned by a web request, you can return that request at any point and keep your process running and doing work. Control C, I don't need a web server running for the rest of this. So the first method of asynchronous programming in Node is callbacks. It's pretty much the de facto standard back to the beginning of Node. And a callback is a function that's passed to an asynchronous process that should be called when it's completed. They're just a specific case of functions being passed in parameters. In JavaScript, functions are first-class citizens. You can pass functions to anything. You can return functions as a result of a function. So you can pass functions around. Callbacks are a system that was developed that says you will pass a callback as the last parameter, and here is the signature of what that callback looks like. And so the anatomy of that callback is we always pass it as the last parameter to an asynchronous function. So if we're going to call something with callbacks, it's always parameter 1, parameter 2, parameter 3, callback. We're also going to expect that the callback signature is going to be error, comma, any other values we want to get back. So you always pass an error object first, and you return that as a falsy object, undefined, null, 0, if you are not throwing an error. Anything in there that returns truthy should be thought of as an error by the handler, and it should not continue. So we have basically a function over here that takes the callback. You'll see it's the last parameter. So we're going to get the contents of a file as UTF-8. So we open up the file name, and if we got an error from the file system, which also happens to return a callback, we propagate that error up. If we didn't, we call back with undefined, so no error, and then the actual data we read from the file. So really we're doing a light wrapper around fs.read file that forces it to be UTF-8. And then when we call it, we actually try to read the file. If there's an error, we're going to console error it. If there's not, we're going to log out the data that was in the file. So this is what's necessary because that file may take a long time to read. So just putting, and Node does have support for synchronous development. You could do fs.readFileSync and read the file synchronously. And if you get any other requests or events that pop up while that file is being read from disk, they will not be handled. So this is pretty much the right way to handle a lot of requests in Node, or callbacks being the original right way. One of the problems with callback, and by far not the most important, but the one that usually stands out, is the idea of callback hell. So down here we have some entirely not Node code, which is what it would look like if we had a fully synchronous path through doing a bunch of work. We're going to open up some config file, throw an error if it's missing, read the file, parse the JSON, That'll give us the name of the real file we want data out of, do the same process there, and return the data. It looks very simple. It's not very nested. You can read through it. It's step by step. That same code put into one big promise looks like this. So this is callback hell. Obviously, using callbacks, you can clean this up. You can refactor out a lot of these functions. This would be a horrible piece of production code. But the general idea still exists. You'll notice you're capturing errors in 1, 2, 3, 4, 5, 6, 7 places. And each time you have to propagate it back out through the system. So it's problematic. The code becomes hard to read. The code becomes hard to maintain. But it's shaped like a dolphin, so, it's kind of awesome. So promises are another method of doing asynchronous code. And a promise is simply an object that allows you to handle asynchronous responses. So we'll get into a little of the definition of that, but the promise object basically has 3 states it can be in. When you first define a promise, it's in a pending state. That means Schrödinger style, it is not completed successfully or unsuccessfully yet. We're not sure where it'll be. It could be fulfilled. If a promise has already been, if all the asynchronous work is done and completed successfully, the promise is fulfilled. Or it could be rejected. If an error was thrown, an exception was caught during the processing of that promise. And the entirety of state transitions looks like this. With promises, once it's fulfilled, it cannot be refulfilled, unfulfilled, rejected, put back to pending. You go from the pending state to either fulfilled or rejected, and you're done. It's a very simple state transition, and it means you can entirely believe what you get out of a promise. There's no reading the value from a promise, and then a couple loops later, it got rejected by some error that came around again. So this is the entirety of state management within a promise system. So the return promise, or deferred response, is just a JavaScript object. And that object has a couple of functions on it, or a couple of methods on it that you can use. .then, where the passed-in function will be called as soon as this thing resolves. The benefit here with promises versus a lot of event emitters is it'll be called when this resolves or if it's already resolved. So there's no chicken and the egg. You can attach a then before you resolve the promise. You can attach it after you've resolved the promise much later. You'll still end up calling your function. The same exists for .catch, which is if it's rejected for any reason, the error gets propagated to a .catch, so you can either work with it or propagate it farther up the chain. And promises are based on a published specification. The promise is A+ spec, so you can read about that. It goes into a lot of details. Actually, even just the front page of promisesaplus.com gives you enough to fully implement a promise library in Node.js. It gives you enough detail that you could write the entire library. And there's lots of them out there, and they're not a whole lot of code. One of the benefits of promises that makes it a little cleaner to work with than most things that turn standard values into objects is it'll automatically unwrap for you. So the result from a function that returns a promise can be a promise or an actual value. You can return a 3, or you can return a promise that represents the value 3. If it's a non-promise, it'll be wrapped if you try to pass it to something else that requires a promise. So you can automatically chain together all your promises, and they will wrap and unwrap the promises as necessary to propagate the values through a chain. So promise unwrapping. So what we have here is this code here. We actually return a promise. And this one here, we actually, we resolve x squared. And here we actually just return x squared. So this one is literally a number being returned. This one is resolving with a promise of that number being squared. And then we're going to use it in both methods. We're going to do it with promise in promise and with value as a promise, and make sure that we get the same result both ways. So we're not changing our calling code in any way other than to call a different function. But both ways, one time we're going to get a promise back, one time we'll get a number. And either way, we get the same result out of it. So we can take our objects and we can use standard functions that aren't at all aware of promises, like this one here. There's nothing promise related in this function, but if we wrap it in a promise, it'll automatically handle that when we get down here. So we just call it, we get number, it'll automatically resolve that value. If we get another promise, you won't end up with a promise that refers to a promise that refers to a number. It just won't automatically wrap it. Async responses for synchronous functions. So one of the benefits to using a callback or promise, either way, some sort of asynchronous call, is it gives you a lot more flexibility when refactoring, reworking, and changing your code. Synchronous calls in JavaScript, any function you write that's synchronous, unless you know it's part of a startup function, you don't care that it's synchronous, you have really good reason to believe it won't need to be changed in the future, which is never true. It's best to always use asynchronous code. So today's requirement on the board is, as a user, I would like my username displayed on the bar at the top of the screen. Great, because we've got this session already here. We don't need any asynchronous stuff. We can just say, we'll get a function that returns HTTP request session username. Why go through all the trouble of making that asynchronous? And then throughout our code, we list tens or hundreds of these things that call the function and grab that value so that we can display it all over the site in different headers and different parts of the site. Everything works great. Okay, next sprint. As a user, I would like the menu bar to display my preferred name from my profile if provided. So all you gotta do is go out to the database and fetch their preferred name, see if it exists. Not a big deal to change the top code, but we've littered this bottom one all throughout our code to refer to that function. That's not gonna work. So we have to look at using promises or callbacks all the time. So we have another thing here, this one, that's generating a random GUID. So here's our quick synchronous way of doing it. We simply return the v4 UUID, and the caller implementation looks nice and simple. We do a try catch, we generate it, and we've generated that GUID. We could implement it as a callback, where even though we're just doing a synchronous value, we go ahead and wrap it in some callback code with the try catch inside, and now we treat it as an asynchronous request. This way we have that flexibility in the future to add an actual asynchronous request if we want to. So we can do a callback that immediately calls back. Same thing with a promise, and it's pretty nice clean code because promise provides a static method to just immediately resolve a promise. So you can just say, I'm doing a synchronous thing here, here's the result, return it, but wrap it in a promise so that if I need to do something asynchronous in the future, the calling code doesn't have to change at all. So the benefits there are not having to change it at all. And if I clear, do that, I'll generate 3 random UUIDs, one synchronous, one via callback, one via promise. They're all fairly simple. When we get to the second step, though, ignore the DB definition here. This is just a really bad fake database implementation that waits a while. So generating synchronously, we can't do it. There's no way that we can do this that doesn't involve having to change the caller implementation. And that was my restriction here that I gave myself was, whatever I change, the caller implementation has to stay exactly the same as it was the first time. So we can't do it. It's just not going to happen. So we're just going to throw an error and tell people they can't get IDs anymore. And basically the change we're implementing and what this database does is I'm making a call to the database and saying, I just generated a GUID, which is a 1 in many trillions time chance of a collision. Let's go check the database and make sure I don't have a collision. So probably not a sensical thing to do anyway, but so in the case of a callback, we simply create a new function that checks if it's unique, which queries the database, looks for matches, and if there's no matches, we call back successfully. If there are matches, we generate an error. And then in our actual ID callback code, if there's an error, we recursively call ourselves. So we're just going to keep trying IDs until we find one that's not taken. This should not take long. Caller implementation is exactly the same as it was before we started. So all of the rest of the code has no idea that we've added this asynchronous step to our code. Promise, same thing. I've created a promise function that checks that same unique value. Same thing here where we make the recursive call if it comes up as a collision. Caller implementation isn't changed from before. So run those. And I've created a widget with a callback and a promise. The other one just had to throw an error because we have no way of extending that without changing the calling function. Lazy promises. So for me and my team. Basically, for a normal promise, as soon as you define something as a promise, as soon as you call that promise function, it's going to evaluate. Whether or not you use the result, it's going to go ahead and process all that code, put it on the stack. Lazy promises extend that functionality. So basically, you can define the promise, but it won't actually execute until you try to call a .then or .catch on it. Until it actually needs the response, it's not there. So this way, we can go over a large set of data and generate promises for it, and only use the ones we're worried about. The couple of benefits, so there's a lot of ways to think about this one. One of the obvious ones is, rather than do this, why not just wait to define your promises until you actually need them? One way to do it. Another one is we can just recall the promise if we need it again. So we don't actually, we can reuse those promises if we need them again. The problem is both of those methods require, if I want to reuse the same promise result, I have to cache it somewhere. I have to keep some sort of store of resolved promises if I'm making them in the middle of my code execution. I have to keep track of what I have and haven't resolved so I know what to use. So like any promises, if you reuse a lazy promise, it's not going to reevaluate. That rejected or fulfilled stays there with the promise, and you can keep referencing it. So lazy promises. So we have a function here that creates a promise for every employee. And our employees, by the way, are right here. Alice, Bob, Chris, Dan. And their file simply states who they report to. I have no idea what this org chart looks like because I literally typed random names in. But I know everyone reports to Irene eventually. So back in lazy promises, we have this thing that goes through and it reads every file in that folder, and it generates a promise that's going to go figure out who the boss of that person is. But if we're using lazy promises, it won't evaluate them. Then we have a function that gets the manager for the employee, and it'll actually go make that request into the file system and read the file. And we have a function that reports on the screen who somebody reports to. And this will go all the way up the chain. So if I put someone at the very bottom of the pecking order, it's going to go through and say, A reports to B, B reports to C, C reports to D. And so I can go all the way up and figure out how they report to Irene. And finally, the function that's actually going to run here, I create all the promises for the system. And then I go in any employees that I entered on the command line, and I figure out who they work for. So, here. So first I'll run it with no employees. And I currently have lazy promises off. So if you look at this source code, there's a line here that replaces the promise implementation with lazy promise. Since I have that off, I'm actually using standard promises from Node. So right now you'll see I actually start up and read every one of those files off the file system. They're not huge files. It doesn't really make a big difference. But I'm actually reading every one of them. I say the employee data is all ready to go. And then I don't query it because I didn't actually put any names on the command line. So I can put Dan in here. And I find out that Dan reports to Frank, who reports to Alice, to Chris, to Lisa, and to Irene. But you'll see I still had to read every file off the list. If I add another user, I end up doing a few more reportings. I don't do any more lookups. I've already looked up everybody. So regardless of promises or lazy promises, you don't double your lookups. You don't open the files a second time. However, if I put this thing to use lazy promises now, first of all, if I do it with no employees, I'm done. It's not going to open any files. It's not going to read them. I've created a promise that says, as soon as you ask me for the manager of a person, I will go open the file and find it unless I already know. So if I run this for Dan, employee data is ready. I'm reading the data for Dan. He reports to Frank. I now open the file for Frank. He reports to Alice. I now open the file for Alice, and I work my way up to Irene. Where that becomes beneficial is, oops, it's very careful about spelling. So if I add a few users in here, it'll interleave all those. And so I'll figure out who reports to who with the minimum number of lookups. So if there's anyone who's looked up 2 or 3 times, like Lisa reporting to Irene, you'll see we have 2 times where it reports that that person is in the chain, but we only read the data off the disk once. So lazy promises give us a good way if we want to do a large set of data and say we only need to access small bits and pieces of this. We may want to access multiple pieces at the same time. Using promises features to combine, we can use promise.all, and we can say, give me the manager of Frank and Dan and Irene, and when those have all resolved, give me the responses. And it'll immediately go look up all 3 of those things and their parent chains, and then once everything's done, come back to us. So lets us be a lot more declarative in our programming. We say what we want, not what order to go execute it in, how we want it to be done. We just declare, here's the data I need. When you're done fetching it all for me, give it back. And they're lazy, which I always approve of. That is, by the way, a library that you have to npm install. So lazy promises are not part of the core Node package. You have to npm install lazy promises. But they are a drop-in replacement for standard promises that simply don't evaluate till you call then or catch. So some of the benefits of using promises over callbacks, they make sense from a functional standpoint. So we've talked a lot in these meetups about writing functional code. Promises are actual objects that you return. So in the standard definition that everyone learned back in procedural development, a function takes some input and returns some output. So we actually have that with promises. A function with some input results in y, and y is a promise object, which we can then add a then, a catch, whatever we want to do with it. Callbacks use f of x comma y returns undefined. So y happens to be a function that's formatted in a particular way, and then as a side effect, that gets called with the results of your data. So you can't really map function A to B to C. You end up with that nested chain of callback hell. So because of that, you can actually say f of x of, or f of g of h of x, and actually chain that together with promises, which you can't do with callbacks. It also promotes a lack of side effects. You get a response object back, you act on that response object, you usually chain them together, which means you're not creating a lot of extra variables that you're kind of bleeding scope in through multiple chains of callbacks. So if we look here, this one's more of an exercise for at home. I have the same code written in callbacks and promises here. And to show a couple of the benefits of those, so you can see, for instance, a lot of it, there's very little change. For getting a user record, a static record, we pass a callback in, and we call back with that record when we're done. On the promise side, we don't take a callback in, and we return a promise.resolve of the record. Again, we're treating it asynchronous, even though it is synchronous. That way, if we ever, I'm assuming get user record, user ID will probably eventually not be a mock, and we'll go to the database. We don't have to change our implementations. Some of the things that change a lot, though, and all the white space in here is so if you actually pull these two up side by side, they line up where the functions start. So format name, for instance, becomes a lot smaller with promises because you can just recursively chain the promises together. You can actually take these things, grab all the name parts, and join them together. Whereas with the promise or with the callbacks, you have to treat them independently, pass them in, get separate callbacks returned back, and push them all together. Get username, same thing. The chain that actually says it reads like you would expect to read this function. I will get a user record, then I will get the name, taking the input of that user record, then I will format the name given the output of get name. It's very simple to see how that follows, just like a synchronous program would. In the callbacks, what we have for that same thing is get user record from the user ID, which returns a function that takes an error in a user record. If there's an error, throw that error. Otherwise, get the user record and follow all the way down this line with what's starting to look like that callback hell feature, minus the else statements. But we get a much cleaner and more readable code with this. And then down here, the actual implementation to call it, because these things that go into then and catch are just functions and they get the parameters passed to them from the promises, a pretty common way to do something that's quick and dirty like this is we can just pass console log and console error directly into the promise. We don't have to actually attach functions. We've done the same, that's not the right one. Done the same thing here, except it's a little more verbose. We have to actually look at that error parameter, determine if it's a truthy value, and if so, console error, otherwise console log. So we have to actually write them out inside of the single function. This is a lot more streamlined. So you can look through here, see how all these things have changed. Basically, the major difference is everything that once had a callback returns a promise. There is one function that's shorter for callbacks, I believe. Everything else is longer. So yes, this one function, get name, because we wrapped it in a promise, get name is slightly longer with promises. That's the only one where you actually end up using more lines of code to express the same output that you want. Oh, and just because I've been running all the other ones. So this thing formats a name. Oop. That one formats a name. They both do the same thing. Great. Okay. So events, if you've worked with client-side JavaScript and a lot of the HTTP server, other things on the Node side, these are based on event emitters. So that's a core part of Node. You can include the event emitter, you can extend it, and events, you register listeners on an event, and then you emit events off to that listener. The problem with events is For a promise, you can actually, like I said, you can attach the then before it resolves, after it resolves, at any point later in your function. It's going to work. It keeps that state. It stays in its resolved state, and it'll execute the then or the catch. With an event emitter and event listener, you have to attach the listener before you fire an event, and this can lead to some issues when you have something that actually emits an event during its construction. If you instantiate something that's an event emitter and then emit during the construction, nothing will be listening on it because it's not possible for something to attach a listener. With a promise, you can resolve the promise during instantiation if there's some error condition, like you asked for the square root of a number and it's not available, they pass something else in. You can actually immediately return from that, and there's no penalty. There's no having to write special code to say, if this thing returns synchronously, handle it. You can also take that promise response, and it's an actual variable. You can pass it around your code. You can pass it to other functions. With an event listener, you have to actually make that part of the listener. There will be a function listening. You'll get some value propagated to you over the function. You may get multiple values passed to you over your function, and then you have to handle marshaling those out and sending them to the other parts of your application. You can't just attach and say, anything I've gotten on my emitter, also give to this other function over here like you can with a promise. And like I said, events allow multiple messages on a single handler. Promises can only be fulfilled once. Depends what you're going for. If you're looking for a message queue, events make a lot more sense than promises. You want to pass more than one message on your queue. But if you're looking for something that has a defined value, when I call this, I get this value out of it, promises lead you to only have one response. And immediate response. So we're going to test event emitters. And what both of these do, promise and event emitter, are they start up. This one starts up a new event emitter, and it immediately logs out that it's going to listen to that emitter, and then later on it attaches another listener and attempts to listen. So it ends up emitting one event, one before and one after, or with one listener before and one after. Promises do the same thing. We actually add a then onto the promise as soon as we define it. Then in our timeout, we add another then 1 second later. And we resolve it immediately. So we've actually resolved it before we even add the first then. And then just so that they run separate from each other, we do the test event emitters, then we do test promises. So you can see here, the event emitter's done after the immediate response. And even though we attached another listener to it later, it never actually got that message because once it's out of the pipe, it's flushed, it's gone. The promise, on the other hand, the promise says something, immediate knows it. The immediate one we attach knows it. A second later, we attach another listener onto that promise, another then function, and because it's already resolved, it immediately calls the then function and tells us the promise has something to say. So we can attach as many then functions as we want to a promise at any point in our execution, and that promise always has our value for us. So putting promises in public code. Callbacks are still the standard. That is what Node is built on. That is what every library out there uses. So if you install something via NPM, you can be pretty sure that unless the person didn't want a lot of people to use it, it uses callbacks as its default mechanism. But you can still use promises. You should probably just support both methods. You want to make sure that people who don't understand promises, don't use them, are making a small throwaway piece of code, whatever their reason for not using promises, that they can still use your Node module. So the easy way to do that is because callbacks have that standard where you are going to pass a function as the last parameter, and it's going to return in a certain way. You just check to see if the last parameter passed to your function happens to be a function. If it is, the person wants a callback. If it's not, you can return a promise. Obviously, there's some caveats here and things to think about. If you're actually expecting to get functions as input parameters, you got to be more careful there. If you're trying to get an unbounded number of functions, then you're pretty much out of luck because you have no way to know if that last one was intended to be another function that was passed into you or if it was intended to be the callback. So 99% of the time you can get away with this kind of check. And so we have that here. Best of both worlds. So this is our library. We have some function that does basically nothing. It turns it to lowercase. But we're using promises. So in our library and the assumed hundreds of other functions we have, we're using promises to make nice clean code. And then finally at the very end, when we actually export this thing out to the public, we take the input data and a callback. If the callback is a function, we run it all and we actually respond with the callback. If we get an error, we catch it and send it to the callback as an error. So this right here wraps our promise that we were doing in due processing steps and returns it back out as a callback if the person wanted that. If the person doesn't give us a function, so chances are this is undefined, we simply return this promise. So here's someone who's out there and they pull in our awesome callback library. They're going to use it with callbacks. And they process data, hello world. They do the same standard callback checking if there's an error, otherwise log the result. Some other user implements us thinking we're an awesome promise library, and they process the exact same data and doing some finagling with console log to attach onto the output some data. But basically, we're binding the console log, we're binding the console error. And so either way, we get hello world out of it. We can call it as a callback. We can call it as a promise. Inside of our code, we can write clean promise code without worrying about the fact that the outside world still depends on promise or on callbacks. So as of 0.12, promises are built into Node. If you're using Node before 0.12, I'm sorry. You have to use an external library, and you have to upgrade. We've said it now. Please. It's been long enough. One of the benefits of these libraries, though, is most of them do provide other benefits on top of just shimming it in for older versions of Node or for older browsers. So a couple of these, Q and Bluebird. Bluebird is probably the most feature-rich library that's out there right now for promises. It actually has a performance improvement over the native A+ promise spec. It does better error handling and catching of errors. It'll actually report a full stack trace on a lot of things, whereas the native one will just say, there was an error in a promise callback. So the Bluebird is definitely worth looking into, as well as adding some nice things like being able to pass an object of named, so it's promise.props. And you pass an array or an object with properties that point to promises, and it resolves all of those as the result of those things. So you can pass every one of the users in your system a promise to go get their boss, and it'll come back as an object with all the users in your system resolving to their boss. So it's quite useful. It's also just faster. And that's it for our talk about callbacks and promises.